These things happen. You can look at the Earth and see the scars. They happen, and they're going to happen again.
With signs dating back to 2003, the United States is about to face the worst volcanic eruption ever in the National Park Zone of Wyoming, called Yellowstone.
There were new cracks in the ground. The ground heated up to the point where the National Park Service had to close some trails.
Fast forward to 17 years later in 2020, the signs have become more evident as the park was hit with multiple earthquakes in 24 hours. Following the results of this volcanic event and the continual increase in geothermal changes, officials have issued an instant evacuation from the zone.
The situation was worldwide famine.
People will be literally burnt to cinder.
Why has the seismic activity increased so abruptly? And what could be the result of this catastrophic event that experts fear is on the horizon? Here's everything you need to know about the Yellowstone supervolcano. Amidst the stunning wilderness of Yellowstone National Park, a series of unsettling tremors have prompted officials to issue urgent evacuation orders. Recently, the park has become a focal point of intense geological activity, raising concerns about the potential eruption of the Yellowstone supervolcano.
There's no technology that I can conceive of that could stop a super eruption.
It would be very difficult for the United States to survive as it is now.
In late May of 2020, Yellowstone was shaken by a significant increase in seismic activity. The U.S. Geological Survey, or USGS, recorded an earthquake swarm, with 20 notable earthquakes reaching magnitudes of 1.5 or higher, along with dozens of smaller tremors. The largest of these, a 3.1 magnitude quake, struck at a depth of 6 miles. This series of tremors, concentrated near West Yellowstone, Montana, is just a portion of approximately 70 quakes recorded in a single day, highlighting the area's volatile nature. Now, Yellowstone is one of the most seismically active regions in all of the United States, experiencing between 700 and 3,000 earthquakes annually. Now, earthquake swarms, sequences of seismic events occurring in a local area over a short period, are not uncommon here and represent about 50% of all seismic activity in the park. These swarms are often caused by shifts in the underground magma, leading to stress on the park's crust. Beyond earthquakes, Yellowstone's geothermal activity has also shown alarming changes. Geysers like Steamboat have become unpredictable, erupting more frequently and intensely. Similarly, hot springs exhibit unusual temperature increases and changes in water chemistry, suggesting a dynamic shift in the underground magma chamber. Vigorous steam vents are releasing more steam and gas, a clear sign of rising heat from below. Now, these signs, increased seismic activity, erratic behavior of geothermal features, and the uplift of ground suggest that the magma beneath Yellowstone is on the move, potentially building toward a larger event. Although earthquake swarms and geothermal changes are common in Yellowstone, the recent intensification of this phenomena has heightened concerns about the stability of the supervolcano. Not too long after, in September 2020, Yellowstone experienced a notable earthquake swarm. 91 quakes in just 24 hours. This seismic activity occurred southwest of Yellowstone Lake, between Heart Lake and West Thumb. While this might sound alarming, Michael Poland from the Yellowstone Volcano Observatory has provided some context. He notes that although this is a large cluster in terms of number and magnitude, it's not the largest the park has seen. In fact, back in 2017, there was a 3-month-long swarm with over 2,400 located earthquakes. Now, some fake tremors were also recorded during this period. They were caused by a vibrosis truck, a giant vehicle used in geological research to send vibrations deep into the ground to create images of what lies beneath. This experiment was a collaboration between the University of Utah and the University of New Mexico, aimed at studying the top of Yellowstone's magma chamber. Despite the flurry of seismic activity and the experiments, the USGS Volcano Hazards Program has kept the alert level at normal as of September 1. Now, this indicates that there are no immediate signs of an impending eruption. Moreover, the natural swarm coinciding with the synthetic experiment provided a unique opportunity for scientists. The presence of hundreds of temporary seismometers meant that this was likely the best recorded earthquake swarm in Yellowstone's history. The park typically experiences about 1,500 to 2,000 earthquakes annually, so this event provided valuable data for ongoing research. Some people on social media expressed concerns about tampering with Yellowstone's volatile geology, especially given the tumultuous nature of 2020. However, the USGS assured the public that the volcano does not know what year it is. And importantly, most of Yellowstone's magma chamber is solid, which reduces the likelihood of a catastrophic eruption. But for how long? Nature can't be predicted 100%, and as a result, the officials have deemed it fit to act fast by making evacuation orders. The evacuation efforts in response to the heightened seismic activity at Yellowstone National Park have been a significant operation involving meticulous planning and coordination between multiple agencies. The United States Geological Survey and the Yellowstone Volcano Observatory have spearheaded these efforts, maintaining constant vigilance over the park's volcanic activity. The urgency of the situation prompted the USGS and the YVO to work in close consultation, monitoring the seismic activity and other geological signs to determine the necessity of evacuation. This decision was based on the detailed risk assessments that considered the likelihood and potential impact of a volcanic event. In coordinating the evacuation, the agencies worked with state and local authorities to ensure a smooth and efficient process. This included the establishment of clear evacuation routes and the setting up of shelters to accommodate displaced individuals. Resources were mobilized quickly, with park rangers, state troopers, and units from the National Guard playing crucial roles in the evacuation efforts. To ensure public safety, several measures were implemented. Roadblocks were set up to prevent access to the most hazardous areas. Helicopter surveys were conducted to assess the situation from the air and to assist in the evacuation of individuals in remote areas. Wildlife relocation efforts were also taken to protect the park's animal populations from potential harm. Continuous monitoring and updates were provided to keep the public informed about the evolving situation and any necessary safety precautions. Now, how big are we talking about when we say big eruption? Professor Bill McGuire, an expert on volcanoes, explains that supervolcanoes generate the most explosive eruptions ever seen. These eruptions are measured by the Volcanic Explosivity Index, similar to a Richter scale for earthquakes, ranging from 0 to 8.
A supervolcano generates the biggest explosive eruptions that we've ever seen. It's a little bit like a volcanic Richter scale, and it runs from 0 up to 8.
For context, tiny eruptions rank at level 1, with more significant events escalating in intensity. The infamous 1883 eruption of Krakatoa in Indonesia was a level 6. In comparison, a Yellowstone eruption could skyrocket to level 8, which means each step up on this scale signifies an eruption 10 times larger than the one below it. Supervolcanoes like Yellowstone owe their fearsome power to the type of magma that they contain. Unlike the runny basalt magma of peaceful volcanoes like Kilauea in Hawaii, Yellowstone's magma is rich in silica. This silica can trap enormous amounts of explosive gases within the magma. When these gases are suddenly released, they cause a monumental explosion. To grasp the magnitude of a supervolcano eruption, compare it to the largest man-made explosions. For instance, the Castle Bravo hydrogen bomb, the most potent bomb tested by the United States in 1954, released energy equivalent to 15 megatons of TNT. However, this is still 160 times smaller than the force a supervolcano could unleash. A Yellowstone eruption would be preceded by unmistakable warning signs, much like other volcanoes. Typically, the ground above the magma chamber, known as the caldera, would begin to rise, a phenomenon observed before the 1980 eruption of Mount St. Helens, where the mountain grew 5 feet per day. This uplift would indicate that magma is moving closer to the surface, fracturing the rocks above. As the magma ascends, it would cause swarms of earthquakes, producing distinctive waveforms on seismographs, the instruments that measure earth tremors. Now, these tremors would start with a sharp spike followed by a quick fade, indicating rock fracturing. These signs would likely prompt the most extensive evacuation effort ever, with regions up to 200 miles around Yellowstone being put on high alert. The final precursor to an eruption would be a type of seismic activity known as a harmonic tremor, resulting in the deep rumbling sound of a large organ pipe. This sound signifies that magma is moving rapidly through the cracks, getting ready to erupt. When the supervolcano finally does erupt, it would unleash pyroclastic flows, fast-moving currents of hot gas and volcanic matter that could destroy everything in their path. These flows are like supercharged avalanches, only much hotter and faster, capable of reaching speeds equivalent to hurricanes and temperatures up to 1,500 degrees Fahrenheit. Surviving such an event in close proximity would be nearly impossible. The intense heat and toxic gas from the pyroclastic flows would cause immediate and severe damage to the respiratory system, with the heat alone being capable of causing instant fatalities. Yellowstone supervolcano is not just any volcanic system. It's one of the biggest on Earth, with the power to influence global climates and ecosystems. The calderas, massive craters formed by past supereruptions, are the scars of this violent history. These eruptions occurred approximately 2.1 million, 1.3 million, and 640,000 years ago, each event spewing vast quantities of ash and gas into the atmosphere, affecting areas thousands of miles away. The volcano's activity is fueled by a hotspot, a plume of hot and light magma rising from deep within the Earth's mantle. Contrary to what some might think, this hotspot doesn't move, but stays in one place as the North American plate drifts over it. This process has not only shaped the current landscape of Yellowstone, but also the eastern Snake River Plain, transforming a once mountainous area into volcanic fields over the last 16.5 million years. Among these fields, the Bruneau Jar Bridge area in southern Idaho stands out. About 10 to 12 million years ago, it experienced an eruption so massive that it spread ash over 1,000 miles away, impacting the environment drastically enough to contribute to the demise of many large prehistoric animals. Today, the supervolcano beneath Yellowstone is a complex system, estimated by the United States Geological Survey to erupt majorly every few million years, with smaller yet significant eruptions in between. These include both explosive releases of ash and quieter flows of basaltic lava. The most recent major eruption formed the Yellowstone caldera about 640,000 years ago, which unleashed the Lava Creek Tuff. Smaller eruptions and lava flows have continued since then, shaping much of the landscape and maintaining the region's geothermal activity. The term supervolcano, that might sound obvious, and rightly so. It refers to a volcanic field capable of producing exceptionally large eruptions that can have global consequences. The Yellowstone supervolcano fits this description due to its capacity to eject vast amounts of volcanic material. For instance, the eruption that created the Huckleberry Ridge Tuff was so enormous it produced 2,500 times more ash than the 1980 eruption of Mount St. Helens. Despite these powerful past events, the current state of Yellowstone's magma chamber suggests a supereruption is not imminent. It's a vast underground reservoir of semi-molten rock, about 50 miles long and 12 miles wide, containing the small percentage of molten material too low to trigger another supereruption, according to recent scientific studies. Nevertheless, the chamber is still dynamic. Research from Arizona State University in 2017 revealed that significant changes in the magma's temperature and composition can happen rapidly, potentially reaching eruptive conditions within decades. From a geologist's perspective, the volcano is what truly defines Yellowstone. According to Jacob Lowenstern, a geologist at the United States Geological Survey, Yellowstone's active volcano is a key aspect. Different people define an active volcano in different ways. To the public, an active volcano is one that's erupting right now. But to geologists, an active volcano has erupted in the last 10,000 years. At Yellowstone, there hasn't been a magma eruption in that time, but many signs show that the system is alive and breathing. There's fire below that could come to the surface in the future. To understand what's happening at Yellowstone, you have to look deep into the Earth's mantle. There, a hotspot melts rocks, which then create magma chambers beneath the Earth's crust. This process acts like a blowtorch, melting the Earth's crust and forming magma chambers high up in the Earth, like the one beneath Yellowstone. When this magma erupts, it causes large volcanic activities. Some eruptions at Yellowstone are among the largest recorded in Earth's history. For example, the eruption 640,000 years ago released 1,000 times more material than the 1980 Mount St. Helens eruption. Scientists have become quite successful at predicting whether a volcano will erupt in the short term. Signs of an impending eruption include significant ground deformation, where the ground moves significantly upward, combined with seismic activity like earthquakes. There also might be a thermal anomaly, where there's an increase in gas or heat flux in an area. One such place is Black Pit in the Norris Geyser Basin, where scientists sample gases and steam. They know magmas are down there releasing a lot of gas. By collecting these gases, geochemists try to understand what's happening 1, 2, or 3 miles below. They analyze the ratios of different gas species, such as carbon monoxide to carbon dioxide or hydrogen to hydrogen sulfide, to determine the temperatures and pressures beneath the surface. While a large volcanic eruption at Yellowstone isn't expected in the near future, Yellowstone is still an active system that could have eruptions in the future. Geologists' job is to stay prepared and monitor what's going on. However, volcanic activity isn't the only concern. Large hydrothermal explosions, which are more frequent and pose a more immediate hazard, also occur in Yellowstone. The original magma chamber is still deep beneath Yellowstone. It's a huge mass that's still hot, trying to cool and crystallize. This hot body contributes to the heat in Yellowstone, warming the water that causes hydrothermal features like fumaroles, hot springs, and geysers. A hydrothermal explosion is a hot water event where something triggers the water in the hydrothermal system to flash into steam, causing an explosion of hot mud, water, and rock fragments. Over the last 14,000 years, there have been an estimated 20 to 25 hydrothermal explosions in Yellowstone National Park. One of the largest documented hydrothermal explosions in the world occurred at Mary Bay in Yellowstone Lake. The explosion crater is about 2.6 kilometers in diameter, extending to the green grassy cliffs across the lake. This lake now occupies the explosion crater, serving as a reminder that hydrothermal explosions are a real hazard, occurring more frequently than volcanic activity in Yellowstone. If a large eruption like those in the past occurred at Yellowstone today, it would be a major national event. Ash would spread over many nearby states, possibly reaching as far as the Mississippi River. Now, while extremely unlikely, it's still important to be aware of the potential risks. Talking about ash, if Yellowstone's volcano were to erupt, the local impact would be immediate and devastating. An ash cloud would darken the sky, covering the area in thick layers of ash. Now, this ash isn't just a nuisance, it's dangerous. It can cause respiratory issues, collapse buildings, and contaminate water supplies. Pyroclastic flows, which are fast-moving currents of hot gas and volcanic matter, would sweep across the landscape, obliterating everything in their path. Lava flows would add to the destruction, burning anything that they encounter. The human toll would be tragic, with many casualties likely. Homes, roads, infrastructure, all destroyed, leaving the region in ruins. The environmental devastation would be immense, with forests, rivers, and wildlife habitats severely impacted. The global impact would also be significant. The ash cloud from the eruption could disrupt air travel across the world. Planes can't fly through volcanic ash, so flights would have to be canceled or rerouted, causing chaos in the aviation industry. The eruption could also trigger a volcanic winter. The ash and sulfur dioxide released into the atmosphere would block sunlight, leading to a drop in global temperatures. Now, this cooling effect could last for years, affecting weather patterns worldwide. Agriculture would suffer greatly. Crops would fail due to the lack of sunlight and ash contamination. This would lead to food shortages and rising prices, creating food security issues. Economies would take a hit as well. The cost of dealing with the eruption's aftermath, from rebuilding infrastructure to providing aid, would be enormous. Many businesses would suffer too, leading to economic downturns. And the psychological impact on people would be profound. The fear and uncertainty of living in the aftermath of such a massive eruption would take a toll on mental health. The loss of homes, loved ones, and livelihoods would lead to widespread trauma and grief. Yellowstone Volcano is one of the most closely monitored volcanic regions in the world. Scientists use a variety of advanced tools to keep an eye on volcanic activity. Seismographs are placed around the park to detect earthquakes, which often precede volcanic eruptions. Now, these instruments can pick up even the slightest tremors, providing early warning signs of increased volcanic activity. GPS stations are another critical component. These stations measure ground deformation, which can indicate that magma is moving beneath the surface. Any significant ground movement could signal that an eruption is imminent. Satellite imagery and thermal imaging are also employed to monitor changes in the surface temperature and gas emissions from the volcano. Gas sensors play a pivotal role in detecting changes in the composition of gases released by the volcano. For instance, a sudden increase in sulfur dioxide emissions could indicate rising magma levels. By analyzing these data points, scientists can make informed predictions about potential eruptions. In the event of an eruption, coordinated evacuation plans are crucial. The Federal Emergency Management Agency, or FEMA, works closely with local authorities and emergency response teams to ensure that residents and tourists can be evacuated quickly and safely. Technology plays a significant role in disseminating emergency messages. The Integrated Public Alert and Warning System is used to send alerts via smartphones, radio, and television. This ensures that everyone in the affected area receives timely information about the need to evacuate. Detailed evacuation routes are pre-planned, with clear instruction provided to residents on the best way to exit the danger zone. These plans are regularly updated and rehearsed to ensure that they can be executed smoothly when needed. Public safety measures are designed to keep people informed and prepare for a volcanic event. Residents and visitors are encouraged to have emergency kits ready. These kits could include essentials like water, food, first aid supplies, flashlights, and batteries. Having these supplies on hand could be life-saving in the immediate aftermath of an eruption when access to resources might be very limited. Clear safety instructions are also provided for both indoor and outdoor scenarios. If an eruption occurs, people indoors are advised to stay away from windows and cover their mouths with a cloth to avoid inhaling ash. Those outdoors should seek shelter immediately and protect themselves from falling ash and debris. Staying informed through reliable resources such as official websites and local news is also emphasized to ensure that people receive accurate and up-to-date information. So, what do you think about all that we've discussed so far? Do you think that the Yellowstone volcano could erupt anytime soon? Well, let us know in the comments section. And if you found this information helpful, make sure that you like this video, subscribe to our channel for more updates, and share this video with everyone you know to help spread awareness.